Electricity surges across the power lines of Ireland. Our current lifestyles dictate an almost insatiable appetite for it. Unfortunately, the planet's natural resources needed to feed that demand are running out.
If we take the Irish situation, we're very much reliant on imported fuel. And as our dependency on the fuel increases, then the risks for the future increase.
Falling fossil fuel supplies, coupled with the dangers of relying on their secure delivery, means that the race is on around the world to find efficient, sustainable replacements to help light our way into the future.
If we're going to look into the future, we're starting now to a revolution, if you like, in the way that we use energy. And we need a new system. We're not talking about tomorrow or the day after, we're talking about 25 years' time. And we certainly have to develop our energy systems to be able to use these variable sources of energy. Otherwise, the whole economy is going to grind to a halt.
In Ireland, we're lucky enough to have some of the strongest natural resources in the world. The challenge now for our investigators is to harness them and to turn that potential energy into power. Experts agree that our heavy use of fossil fuels, especially for electricity production, means that demand will soon outstrip supply. In the future, there will be less and less oil coming into reserve facilities like that on Whiddy Island in West Cork. Dr. Colin Campbell is an oil industry expert who has worked in the field for over 20 years. He has published extensively on the subject of global fuel supplies and has been looking at the Irish situation.
Ireland's prime concern is electricity supply. 60% of Ireland's electricity is now made from natural gas. And in the past, the Kinsale Head field off Cork was supplying this gas, and that was a very happy situation. But like all oil fields and all gas fields, it began to decline and is now almost exhausted. Ireland then built a pipeline to Scotland to tap the North Sea, but now the North Sea is heading into steep decline. That means that Ireland becomes right at the end of the line, tapping gas initially from the Arctic oceans off Norway to Siberia. And there will be an increasing number of very hungry people up the line before it reaches us.
Our lifestyles are such that we use huge amounts of electricity on a daily basis, but rarely think about where it's generated from. All of our electricity is managed by the national grid, which is the backbone of the power system. The grid is an interconnected network of high-voltage lines and cables that go right around the country. 90% of the electricity we use comes from a combination of fossil fuels such as gas, peat and oil. However, with those fuels in severe decline, we need to find alternative, naturally occurring renewable energies to replace them.
Right now, renewables are very important. They account for about 10% of our total generation. But going forward, they're going to be increasingly more important because the government, as you know, has set a target of 33% of renewables by 2020. And we're on target to meet that, but it is a challenge.
Because of our position on the edge of Europe, Ireland receives the full force of the Atlantic Ocean on its western shores, which makes our wave energy one of the most powerful in the world. Tony Lewis at the Hydraulic Maritime Research Centre in University College Cork is working to develop new ways to harness that power.
At the Hydraulics and Maritime Research Centre, the main facility that we have is the Ocean Wave Basin. And this is a facility where we can create waves which model the real ocean in the laboratory. And this facility is unique in university in Europe. So here we have the waves running in the wave basin, and you can see that the computer is controlling the wave paddles, and they're moving in such a way to create a wave pattern in the tank, which is like you observe in the real ocean.
Tony Lewis has been using this wave tank to test a number of different devices that are attempting to create power from the waves. One of the systems he's particularly interested in at the moment is known as the oscillating water column. The device effectively looks like an L on its side, with the short part visible above water. As the water enters the open chamber, it forces the air upwards. The force of this air turns a turbine, which in turn generates electricity. When the water recedes, it creates a vacuum, and air rushes in from outside to fill it, and the turbine continues to turn in the same direction. It's this continuous motion of water and air which produces electricity. This was the theory which Tony had been testing for some time in his wave tank facility, with some good results.
About 6 years ago, I was approached by Michael Whelan, who I knew from a long time ago from another marine context, and he was looking for a project. So I suggested that maybe he would look at the oscillating water column system and try to develop that into a commercial machine. And really that's where it started, and Mike got very excited about it all, and really it's gone from there, and the OE Boy has developed out of that with the ideas of Mike and his partners in the Ocean Energy Limited company. And this is the model that we started with, the 1 to 50th scale model of the OE Boy. And this was tested here in our tank as the first stage of this development protocol.
Following the success of the initial prototype, Tony continued to work on a series of larger models, which he tested in the wave tank under a variety of conditions. Mike Whelan has come to see how things are progressing with the latest model, which is at the 1 to 15 scale.
Okay, so Mike, you can see that Tom is running the extreme waves here now, and you can see the motion of the model is really no worse than it was when we had the normal waves running.
Okay, John, that's very good. I'm glad to see that now, because I'm happier about the whole thing now, so we're ready to go ahead into the final phase of the project.
The next stage for Tony and Michael is to build a quarter-scale model, place it out in Galway Bay, and see how it will survive a real West Coast winter. Ireland's geographical position ensures not only extremely strong wave energy potential, but also very high winds, thanks to the storms coming off the North Atlantic. Ireland's wind speed is over 7.5 metres per second, which is well above the European norm. This considerable power is currently being harnessed through wind farms throughout the country. Wind is the principal source of renewable energy currently being fed onto the national grid. And because Ireland's grid is relatively small, the percentage of wind power connected to it is one of the largest in the world. Eamon McKeogh, based in Cork, is combining engineering and computer technology to maximise the electrical grid power which can be utilised by these wind farms. Even though wind power penetration is high in Ireland, the problems of variability and storage of renewable energies like wind are still major issues for Eamon McKeogh.
Due to the variable nature of the wind farm production, there will be times when there will be a surplus which could be dumped. We want to ensure that we capture a maximum amount of energy and that no energy, none of this renewable energy, is lost.
When the wind blows, the blades turn, the generator generates electricity that's pumped onto the network. That means then that we're able to back off other generation, gas-fired generation or oil-fired generation. So we're using less fossil fuels. When the wind doesn't blow, then we have to obviously bring on the other generators. So we are now generating electricity from other means, be it coal, gas or oil.
Because of the energy required to fire up a fossil fuel power station, it's not viable to switch back over to the wind farms immediately if the wind starts blowing again. In this situation, the wind is generating electricity, but this power is not being fed into the grid and is being wasted. This will happen more frequently in the future as more and more wind power is connected to the grid. Eamon McKeogh and his team want to try and capture that power and store it. The approach that they're taking is to use the concept of a well-tested technology, pumped hydro storage. He aims to build a hydroelectric plant which will function along the same lines as Thurlough Hill in County Wicklow.
We're here at Thurlough Hill, which is a very good example of pumped hydro energy storage. This is a technology which we will use to integrate larger amounts of wind energy into the grid system. The way in which the pumped hydro energy storage works is that water is pumped from a low-level reservoir to a high-level reservoir where it is stored. When it is in the high-level reservoir, it has potential energy, and that potential energy can be converted to electricity at a later stage.
The upper reservoir at Thurlough Hill stores about 2.5 million cubic metres of water. This water can be said to have potential energy. Water by itself cannot create energy. In this case, the water is released from a height of 300 metres through a tunnel with a diameter of 5 metres. The force, due to gravity, of its downward surge will turn a turbine and create electrical energy within seconds. His theory is that he can harness a large proportion of the electricity, which might otherwise be wasted from the wind farms, and use it to pump the water to an upper reservoir where it can be stored as this potential energy. What makes Eamon's project different from existing systems is that he would be using exclusively renewable energy to pump and store the water.
Well, I think it's important to emphasise that this is an application of pumped hydro energy storage in an innovative way. This is pump storage which is specially designed to meet the requirements due to the variable input of power to the grid system.
The variability of wind power means that the grid operators must always be able to bring on other fossil fuel power stations when the wind is not blowing. However, if we could accurately predict when the wind would blow and when it wouldn't, theoretically we could be prepared, and instead of relying on energy supplements from the fossil fuel stations, we could release the stored green energy to compensate for the periods of low wind. To function correctly, this would require sophisticated information technology.
We've been involved in wind energy forecasting research over the last 5 years, and we've been part of a European-funded research group which has looked at different methods of forecasting and improving the accuracy of forecasting. We have a system which is called an ensemble prediction system, and we believe it's one of the best in the world in terms of accuracy and reliability.
The particular system here is called an ensemble because it's made up of 75 different forecasts. That allows us to quantify what the error in the forecast of wind power is in advance. So if there's a very large error, then you might need to bring on more reserve plant. If it's a very small error, then you'd bring on less. So an accurate wind power forecasting system and the ability to quantify the error allows us to maximise the amount of wind on the system and reduce how much fossil fire generation is actually used. So that's an environmental benefit.
I think that's what makes this research so interesting, is that it is combining two technologies of wind energy and an older technology, which is the technology of hydroelectric power. It gives like a hybrid, a new energy source, a new energy system technology going into the future.
Meanwhile, things have moved on from the Wave Tank Test Centre. Michael and Tony have built and placed a quarter-scale prototype in the Marine Institute test site in Galway. It has been moored out in the bay over one of the worst Christmases in years. Michael has come out to see how it fared.
Looking very well now. We're very happy the way she's riding it out there. I just want to check the situation with the shackles there, and other than that, she's looking fine. We're very happy with it. She's a bit weedy, mind you. She's after 8 months of sea, she's bound to have a little bit of green growth on now, but she's looking good otherwise.
Tony and Michael believe that it is the simplicity of the design which has allowed it to withstand such a fierce drubbing by the ocean. The lack of moving parts and the extent of the mooring system holds the key to what they hope will be a successful venture.
This model is built as approximately 40 scale of a full-scale size It's built to suit the wave climate here in Galway Bay, which is approximately quarter-scale wave climate of the Atlantic Ocean. On the full-scale prototype, each unit will produce enough electricity to power about 600 average homes. Next step now is we head off to Devon early next week to check the turbine, and we hope and we expect to produce a turbine just as good as the hull. If we get those two married up together, I think we've got a success.
Well, certainly this company, LMC, have been developing the generator for the OE buoy, and this generator will be coupled to the turbine to generate the electricity when the air is flowing out of the OE buoy chamber. So basically what they've done is they've put 3 generators together to get the power level that they want, and today what we're seeing is a test really of the capability of this system to generate the power which we expect in the Galway Bay test site. One of the situations is when we have the air power coming out of the OE buoy, even though the average might only be 5 kilowatts, in every wave you probably get a spike of maybe 40 or 50 kilowatts. So this generator has to be able to absorb that and control the turbine to run at a constant speed. Whoa, it's vibrating somehow, lads.
It's either bearing problem.
Could well be a bearing.
Go check another bearing in.
Yeah. That's much better, isn't it?
Certainly when we were running under the full load at constant speed, there was some heating in the bearings, but that is not really a big difficulty because in the full scale it won't be running at constant speed, at constant full power all the time, and there will be an air cooling system installed to take away this heat. So in the Galway Bay tests then, we don't expect this to be any difficulty at all. Here we are now in Galway docks, and the turbine generator, which was fabricated in Devon and worked very well over there, has been delivered. It's now been fitted onto the hull, and the whole system is being connected together. And then the system is then being commissioned to make sure that it works in a satisfactory way before the hull is taken offshore. So inside in the chamber here then the water rushes in and out, and the water level inside is rising and falling, and it then is driving the air out through the orifice, through the pipe there, into the turbine. The turbine spins to generate electricity. And as the water falls, the water level falls then, the air is sucked back in, and the turbine still continues to turn in the same direction, generating electricity all the time. So the air is continually rushing inwards and outwards through the turbine, generating electricity. Here we are on top of the device now at the air turbine. And now what we're doing is we're running up the blower, and the blower is simulating the airflow coming out of the oscillating water column, driving the turbine to check that the system is working properly and generating the electricity. So the turbine is now starting to run, and the turbine starts to run up, and then the generator starts generating electricity, and away we go.
It feels great. It really feels great. We're coming so close to it all, and we're very confident what we've put on board. This turbine has been very well constructed. The whole thing has gone very well, and I think that we could be very close to creating electricity within the next week to 10 days.
We nearly sucked the welder in. We nearly sucked the welder in down below.
As the buoy is towed out with its turbine fitted for the final phase of testing, investigators in Ireland and around the world are part of the latest drive to source and develop new sustainable energies. But realistically, is it achievable?
The target of 33% of our electricity from renewables by 2020, in one sense, is quite challenging, and we'll have to work very hard to meet it. But in another sense, it's quite a minimal target, because if you look at what the price of oil will probably do over the coming couple of decades, it's just going to go through the roof, you know, and the price of energy generally will become very precious. And if we're actually concerned about creating a stable economy, we need to stabilize our energy prices, and renewable energy does that. I would draw the analogy with the rural electrification program way back when. It was known that this would be very important for the development of the country in the long term, and so it was just done. The economics were actually secondary to the knowledge that we just had to do it, and I think that that kind of thinking actually has to apply, and apply quickly in the case of our change to sustainable energy.
I look every morning, every noon, and every evening. I'm continuously looking out that window, all the time, watching it. Even from my bed, I can see it.
After almost 6 years in the development and production of their wave energy buoy, Tony and Mike will now know if their machine can actually produce electricity at sea.
Well, I think today is one of the most exciting days because it's the first time we've been out at sea with the full electrical generator system on board, and we're going to see for the first time the firing up of the generator, and then hopefully if the wave energy level is high enough that we'll start to generate electricity. And this is really the first time that a wee buoy has been generating electricity at sea using the wave energy in Galway Bay.
Because the buoy is at the test phase, it is not connected to land via cable, so the electricity generated has to be burned off. For now, Tony's main concern is that the device can actually generate power.
This is the moment of reckoning now. We'll be all connected up in about 5 minutes and we're going to run. Our turbine is going to run. So we'll see what she does, okay? Best of luck. Thank you. We need it now.
Turbine armed.
Turbine armed. Into here now. This is the crunch time, guys.
All right, there's something happening.
What's happening now? It's trying to run.
Something happening again there now, look on the screen.
Yeah, it's trying to run. It's doing this unstable stuff again, Darrell.
Will I just go and check the...
Yeah, go out and check
the blades itself. I'll go up on top and I'll...
No, she's going up. She's 300 RPM now.
Super. Okay.
Go up and check. Make sure she's spinning up there. Yeah, she got nearly to about 850, and then but there wasn't enough air blowing.
Keep her going, yeah.
To keep her going there, so she's actually says, okay, I'm not getting enough power, so I'm going to have to switch down, you know. So
she'll try again now.
Try again in a minute now.
She'll keep trying again.
Hang on a second. It's going back up again now. It's going back up again now. Yeah, she's powering up again now.
See, we need to fool around with that start speed they've set as well, like.
Yeah.
Right, to allow it to slow down a little bit too, like, you know.
It's going up now. It's going up above 1,000 now.
That's good.
Well, certainly you can see now that the current values, that's the electrical current, goes positive for some of the sequences during each of the waves. So I mean that's very encouraging now. It means that this device is generating electricity and producing power into the load.
Thank you, Tony, for all your help over 7 years.
Good man, Mike. Good man. No better man. Well, I think we've certainly achieved something today with generating the first electricity, and really this starts now into the next phase of the program where we'll be monitoring the electricity output over the winter, and then from here on, then who knows where we'll end up.
I'm very happy today, went very well, and I want to take Tony ashore to have a celebration drink.
Good man. How do we?
Let's go.
All right, so. If you indicate and look into the future to our energy supplies, really the security of supply issue is going to become very, very, very prominent. And we need to harness all of the renewable energies available to us, not only wave or wind or biomass. We will need them all into the future.
There is no doubt that there are many challenges ahead for all investigators in renewable energies. Connectivity from ocean devices will be complicated and expensive. Storage options are still at the development phase, and all will have to be tested at full scale to ensure viability. However, it's also true that Irish investigators are uniquely placed to capitalise on our tremendous natural resources. With each new development, we're inching closer to the possibility of Ireland becoming entirely self-sufficient for electricity production in the future. And that surely is a prize worth striving for.